right, so now we can get into chemical reactions. All right, so this is basically the definition. So chemical reactions occur through forming or breaking chemical bonds. And whenever that happens, you basically get new materials. And this requires energy or it puts off energy. So there's some sort of energy exchange. And a chemical equation is kind of like a physics equation in the fact that what's on the left has to equal what's on the right. Okay, so basically the units, or not necessarily units, but just the amount of atoms has to be the same. All right, so chemical equations. These are some more terms that you need to know. So reactants, these are substances that are before the reaction. So that would be like these guys right here. Those are the reactants. The products are the substances after. So these are the products. And see this like yields, this arrow, that's called a yield sign. This is a yield. That's kind of like the equals. All right, and so this says that the chemical symbols and formulas needed for quantitative purposes. So on this first one, everything's good. Like it's all balanced. You can see that there's one carbon over here. Let me switch my pen color for a minute. You can see that there's one carbon here and two oxygens here. There's one carbon here and two oxygens here. So everything's good. But if you look at this one below, see there's one carbon over here and two oxygens here. But on the right side of the equation, there's one carbon and only one oxygen. So it's not balanced. So that's what we kind of have to do in this next section is we have to figure out how to balance equations. So it gives you this other definition that I think is a pretty important one, law of conservation of mass. This is where atoms are neither created or destroyed. So whatever is or was, here as far as atoms are concerned, is still here. Okay, so like however many hydrogen atoms there were, there still are. Okay, so it's just saying that there's a law of conservation of mass. Now, you can get into some more extreme sciences that talk about like radioactivity and things that are causing those atoms to go in and be different things, but we don't get into any of that. So I just kind of want you to think here like the atoms are neither created or destroyed. There's so many atoms, and that's just what stays. Okay. All right. So you can see here that on the second bullet point here that it says that you will be in charge of changing the coefficients in front of the chemical formulas, not the subscripts. So this number right here is a coefficient. This number right here is a subscript. So coefficient, subscript. There's a big difference. You cannot change this number right here. You cannot add numbers like that. You cannot change numbers like that. The only thing you can do is add these types of numbers. This is another coefficient. Okay, these are both coefficients. And I will show you why on this slide. So you can see from this picture that this C means, that there's just one carbon. This oxygen just means that there's one oxygen. You can put two oxygens together and this becomes an oxygen molecule. Okay, when two atoms of oxygen are joined together. You can put a carbon and an oxygen together and join those two things together. That's totally fine. You can put a carbon and two oxygens together and now have CO2. So this one was carbon monoxide, this one's carbon dioxide. Okay, whenever you change that little 2 right there from, this was just 1 and then you put this 2 down here, that completely changed what this whole molecule was. It is no longer carbon monoxide, it's carbon dioxide, which is a completely different thing. But if you put this 3 in front here, like of the whole carbon dioxide molecule, then that just says that there's 3 of those. Okay, so that 3 just tells you how many molecules there are. Okay, so let's give an example here. This one is showing you an example of balancing an equation that is dealing with polyatomic ions. Okay, so polyatomic ions were in chapter 9. It was that table 9.3. So it's still, I still have that paper or that reference page on D2L that you could look at if you don't want to flip to that in the textbook. All right, so this is a really good example of balancing equations and kind of how to set them up. All right, so it first tells you, it's going to give you this really long kind of wordy example, but just kind of read between all of the words a little bit. So this says one type of water hardness is caused by the presence of calcium bicarbonate. So that's this right here. Just kind of went through the other one. And it says, here, let me change that really quick so you can see the other one. I'll make like a little dot right there. One way to remove the troublesome calcium ions is to add sodium carbonate. Okay. The reaction yields, that's an important word, sodium bicarbonate and calcium carbonate. Okay, so the first step that you have to do is to actually write the equation. So it's already giving you the formulas. You just have to put them in order. So just the same order that it gives you in the word problem. So calcium bicarbonate, that's this one, plus this Na2CO3, write that, yields, that was this word right here, this sodium bicarbonate plus calcium carbonate. Okay, so that's your first step. The second step is to actually do an inventory and to see how many of each kind of atom that you have. Now, I said something about polyatomic ions. Remember that a polyatomic ion is almost like they're so closely bound together that they almost act like their own individual atom. So if you were looking at the polyatomic ion table, you'd see this HCO3, which is bicarbonate. Okay, so you can actually, when you're balancing equations, you can just list those polyatomic ions as if you would if it was its own individual atom. Okay, so when you do an inventory for something, like if you were working at Walmart or some retail place, you do inventory, you see how much you had and then how much you need, right? So that's what you're going to do for the reactants and the products. Remember, this side right here is the reactants. This side right here is the products. So you go through, and I want you to see something. See how I'm going to change my pen color again. See how there's one calcium here and one calcium here? So that's how they did this line right here. They did it, and look, they put calcium on the same place, and I would strongly suggest doing that whenever you're doing an inventory. Then they went over and they said, oh, okay, here's bicarbonate, and there's 2 of them. Okay, so there's 2 over on the reactant side, but how many is there over here on the product side? There's just 1. Okay, so write that down. Then over here on the reactant side, there's how many sodiums? Well, there's 2. But how many is there over here on the product side? There's just 1. And then over here on the reactant side, there's 1 carbonate, and over here on the product side, there's just 1 carbonate. Well, is that balanced? No. So what's the only thing we can do? The only thing we can do is put a coefficient, which is a big number in front, right? We can't ever put subscripts. So we go over here and we say, okay, there's 1 calcium, 1 calcium. So that's good. There's 2 bicarbonates, and then there's 1 bicarbonate. So that's not good. So the only thing that you can do in a situation like that is to go up here and add a 2. Well, when you do that, that 2 multiplies to that 1 sodium, but it also multiplies to that bicarbonate. This is all bicarbonate, by the way. So now you have 2 bicarbonates. but you also have 2 sodiums. Well, did that just fix all of your problems? Yeah, because you needed 2 bicarbonates and you needed 2 sodiums. And then you had one of the other things. So everything's balanced. All right, and this is just showing you like a ratio. All right, this is the ratio right here. There is 1 calcium bicarbonate. Okay, so 1 calcium bicarbonate, 1 sodium carbonate, that's these numbers right here. All right, yielding 2, that's that number right there, to 1 calcium carbonate. Okay, so that's just showing you how you can get the lowest whole number ratio. All right, I got to stop the video and I'll start another one.